Hi everyone, this is Indra. Welcome back to my channel. Today in this video, I am going to discuss about very important and very useful theorem, that is Pythagorean theorem. It is also called as the Pythagoras theorem. Here I will discuss about that. And the Pythagoras theorem is going to be discussed here by the visualization method by using the Geogebra software. Please watch this video till the end. Okay, first of all, let me say something about the Pythagoras theorem. Please remember that the Pythagoras theorem is always applicable only in the right angle triangle. For using the Pythagoras theorem, the triangle should be a right angle triangle. Here we can see a right angle triangle, triangle ABC. This is here right angle at the point A. We can use the Pythagoras theorem only in right angled triangle, and the side opposite of this right angle is called as the hypotenuse. Here this side BC, which is opposite of this right angle of this 90-degree angle, the side BC is called here is the hypotenuse, and this vertical side is just the height, and this is the base side. And the statement of the Pythagoras theorem is that it states that the square of the hypotenuse, the square of this hypotenuse side, is always equals to sum of the squares of the remaining sides in right angle triangle. Here this is the hypotenuse. Here the BC is hypotenuse. BC square should be equals to the sum of the squares of the other sides. Here, so BC square should be equals to AB square plus AC square here in this triangle ABC, which is right angle at the vertex A. Okay, and the geometrical meaning of this Pythagoras theorem is that here A square, here the squares, three squares. Here we can see that in this diagram we can see that the three squares here. These three squares are formed by the sides of this right angle triangle. Here by taking the hypotenuse, here a square is formed here. This square is just formed by taking the side hypotenuse, and by taking the height side, this side, here the next square is also formed, and similarly by taking the base side, here this square is constructed here. And the geometrical meaning is the area of the square formed by the hypotenuse is equals to the sum of the area of the squares that are formed by the remaining sides. This is the geometrical meaning of Pythagoras theorem. The area of the square which is formed by the hypotenuse is equals to the sum of the area of the squares which are formed by the remaining sides. This is just the geometrical interpretation of Pythagoras theorem. Okay, here in this video I am going to illustrate by using the Geogebra software for this Pythagoras theorem. Please watch this video till the end. Okay, let me just open that software. Here we can draw the different things in Geogebra software. This is very amazing software. Okay, let me just open that software. One second. Okay, let me just open that software. Here this is the Geogebra software. Okay, let me just view the algebraic view. Okay, let me just use here algebraic view. Just a moment. Let me take the algebraic view. Okay, it is just loading. Yeah, this is Geogebra software. Okay, I am going to illustrate. I am going to discuss, interpret about this Pythagoras theorem by this software. Okay, first of all, let me make a right angle triangle. Okay, let me use the different tools. Okay, let me first use the segment with the given line tool. Okay, let me make a segment here. Okay, let me name this segment as the A. Okay, here the length is needed. Okay, just here I am entering the A. I am just going to make the slider here. Okay, here I have created a slider which is here. We can change this length of this line segment. Okay, let me go to the settings, sheet settings. We can take the any length. Okay, just changing. Okay, let me just go to the setting to change the length. Is it's a range. Okay, it's name definitions. Okay, let me use the select tool. Okay, just go to the setting. Okay, here the next point C is okay, let me just delete this point. Okay, it is unnecessary point here. And let me go to the setting of this line segment, and here the definitions, advanced settings, still okay. Here the range is not given here. Okay, here I am going to make the slider here, and let me go to the settings of this slider. Okay, and here from minimum value we can change the minimum value is the 0. It is just the length starting from the 0 to just the 10. Okay, 10 units, and the increment is just the 1 unit. I'm going to first make the slider of this line segment AB. Okay, here this is a slider. We can take any value from 0 to 10 by the increment of 1 unit. Okay, and I'm here. First of all, let's construct a right angle triangle. Okay, let me make a circle with a given center and the radius. Okay, this is just taken as the center and the radius is just taken as the B. I'm just going to make the slider for the radius also. Okay, create slider. Okay, here let me, okay, here the slider is visualized here. We can take the any value. Okay, let me just change the value, its value. Okay, here we can change the value of the radius. Okay, just making the slider, and let's go to the setting of the slider, and its value ranges from 0 to 10. Okay, let's change, sorry, and the increment is just taken as the 1. Okay, here I have just created the slider for the radius and the slider for this line segment AB. And let me make a right angle at this vertex A. Okay, let me make the right angle here. The perpendicular tool, we can use the perpendicular tool. Okay, the point and the line to which the perpendicular is here. This is the perpendicular line, and let's find out the point of the intersection of this circle and this perpendicular line. Okay, just finding the intersection point. Okay, intersection point here. This point C is just the point of intersection of this perpendicular line and the circle. Okay, let me make the triangle ABC just by connecting these 3 points. Okay, let me just make the triangle just from C to B. Okay, here just I am going to make a right angle triangle. We need right angle triangle to illustrate the Pythagoras theorem, because our Pythagoras theorem is totally related with the right angle triangle. It is only applicable for the right angle triangle only. Okay, so here I have just created triangle ABC. Let me hide these unnecessary circles and perpendicular lines. Okay, and here we can change, we can use the different value of here, different value of these sides. Okay, we can change. So I have just created the slider. This is the benefit of the slider. We can change here, we can take any value. And here in this triangle, okay, let me measure the angles here. It is a right angle triangle or not. Let me just measure the angle of this triangle. Okay, here we can see that this angle at point A, angle at the vertex A is exactly 90 degree. Here we can see that. So the opposite side of this right angle is just the side BC, is just the hypotenuse, and the remaining sides are AC and AB. Okay, these are the okay, let's just show this 90 degree angle only. Here in this step we have just created a right angle triangle here, and it is here the bearing. We can change the here the sides. Here we can change. I'm going to just animate this Pythagoras theorem. So I have created here the this slider. Okay, and the next step is just making the squares. Okay, let's take these three sides, hypotenuse and the remaining two sides, and create the corresponding squares on these sides. Okay, let me use the polygon, regular polygon tool, and okay, just I am going to make the square here. The for vertex is 4. Okay, yeah, let me just a little bit zoom out. Okay, this is mistakes. Okay, let me just a little bit zoom out. Here in this step we have just created a square by taking the side as the hypotenuse. Here the side of this square is taken as the hypotenuse. By taking the hypotenuse as the side of the square, we created this square. Okay, let me just take the new color to it. Let me change the color of this square. Okay, we can change the color. Okay, this blue color square, okay, which is formed by just taking the hypotenuse. Okay, and similarly we can make the squares on remaining two sides also. Okay, let me do the same thing for these remaining two sides, just creating the square. Okay, here this poly 2 is the square which is formed by taking this perpendicular side. We can use the different color to it also. Okay, let me use the different color for this square. Just changing the color. Let me change this is the red color. Okay, and similarly doing the same thing. Okay, doing the same thing for the base side also. Okay, let's construct a square by using the side of the triangle. Side is the base side of this triangle. Okay, let me just create the regular polygon is the square. Okay, okay, just doing the same thing here. Yeah, this poly 3 means it is the square formed by taking the side is the base side of the triangle. We can use the different color to it. Okay, let me use the next color for this. Let's use this color. Okay, here we have just created the three squares by taking the three sides of this right angle triangle, hypotenuse and two adjacent sides. Okay, and let me just use this slider. Here we can change the size of this squares. Size the size of the square is changed due to the change in the sides of the right angle triangle. We can take any length of the side of the squares here. Sorry, side of the triangle, right angle triangle. We can take any length. Here the slider is made here. Okay, we can adjust here. Okay, and let me show the area of these squares. Okay, let me go to the select tool and the setting for this. Okay, and here from the setting we can show the value here. Value means just the area. We can show the area of this. Okay, area is here shown is the 130 square unit. Okay, let's do the same thing for this poly 2. Okay, just showing the value. Okay, value of the area of the c squares. Okay, so that that will be very easy to understand. Okay, here in this step we have just uh, created the three squares just by taking the three sides of this right angle triangle. Okay, let me change the sides. Okay, let me change the measurement of the sides of this right angle triangle here. First of all, let me take these sides. Okay, here. Okay, we can show. Let me just take these sides. Okay, just take these sides and we can show the length of these sides also. Okay, this is just 6 unit, and doing the same thing for these also. We can show. Sorry, here the mistakenly it is deleted. Okay, let me undo it. Okay, we can show the length of each side here. Okay, just showing the value. Okay, this is just 9 unit, and doing the same thing for this hypotenuse also. Just value. Okay, here the value is shown here. Okay, here this is 27. Okay, this is, I think this is the area of this right angle triangle. We don't need the area of this right angle triangle. We need the area of the squares. Okay, let me just go to the setting for this triangle, and then okay, just name, and for this side, okay, this is just the value. Okay, this is good. Okay, here we have just shown the value of the area and the length of the each side. Okay, and then let me just animate this. Let me change the value of, okay, this side AC, sorry, AB. Okay, let me take the value of this AB is the 10 unit. When the AB is 10 unit, and the here the AC is taken as the constant is the 6 unit, and then at that situations the hypotenuse will be the length of the hypotenuse will be 11.66 unit, and at that situation the area of this square, this square which is formed by the hypotenuse is 136, and here this is 136 is equals to the sum of 36 plus 100. Okay, so we can say that uh, the area of this square which is constructed by taking the hypotenuse is equals to sum of the area of the squares by taking the remaining sides of the right angle triangle. Okay, let me change the value of the side AB. Okay, let me take just the 9 unit. When the AB is taken as the 9 unit, just by taking AC is the constant C, a constant 6 unit, and then at that situation the hypotenuse will be just 10.82 units, and at that situation, at that measurements of the sides, the area of this square which is formed by the hypotenuse is here 117 unit, and which is 117 is equal to 36 plus 81. 36 plus 81 gives 117. Okay, let me change the side AB once again. Let me take the side AB as the 6 unit, but just by taking the AC as the 6 unit, and at that situations the hypotenuse is just 8.49 unit, and the area here, the area of this square which is formed by taking the hypotenuse is the side is equals to this area equals to sum of the area of these two squares, 36 plus 36, 72. Okay, here we can see that, and we can take any value of these sides. We can say, let me take this side AB is the constant side and change the side AC, and due to change in the side AC the hypotenuse will be also changed. Okay, okay, let me just change here. Here I'm just changing, and here the area are also changing here, and And here the constant thing is, the conclusion is, the area of this square which is formed by the hypotenuse is equals to sum of the area of the squares which are formed by the remaining sides of this right angle triangle. Okay, here the area of this square, this big square, is 149 square unit, and here the sum of this area of these two squares, 49 plus 100, also gives 149. It is matching here. Okay, here the 100 plus 36, 136. Okay, let me just change the value. Here 100 plus 100, 200. Okay, we can, this theorem, this statement is valid for all the measurements, but the very important thing is the triangle should be right angle triangle. It is only applicable for the right angle triangle. Okay, let me just take the value of the b as the 6 unit. I am changing just the value of the. Okay, here in this triangle, in this right angle triangle, here the side AB is 8 unit and the side AC is 6 unit, and at that situation the hypotenuse will be 10 unit, and the area of this square is just 100 unit, which is equals to sum of the area of these two squares. 36 plus 64 gives 100. Okay, here we have just proved that, we have just visualized this Pythagorean theorem, okay, by using this Geogebra software. Okay, this is very, very interesting and very useful software. Okay, in our next video we will discuss more about the Pythagoras theorem. So please keep watching, keep loving this channel, and don't forget to subscribe this channel. This much for today. Thank you everyone.